All right, well, thank you all for coming to the first in our series of lunchtime talks in science and mathematics this semester. Looks like we have a full house, so a few people are going to have to scrunch in. I think we may have a couple of extra chairs right there. A few people are still looking for chairs. We have a couple up there. So it's my pleasure to introduce our speaker for today's talk. He's also here as our keynote address for the Martin Luther King Jr. Week, which we are celebrating all week. We had a lecture by Dr. Crowther yesterday who gave some of the background of our speaker's background and history for the past 50 or so years, which was very enlightening and hopefully prepared some of you for today's discussion as well. Bringing Mr. Moses here has been a collaborative effort between Dr. Crowther and the history program, as well as both the institutional and the STEM Title V grants, the mathematics program, CLO. So it really was a group effort. I'm pleased to have been able to play at least some small part in that. Before I get too much further, I do want to make sure everyone here is probably aware, but if not, Mr. Moses will also be speaking at 7 o'clock tonight over in the Carson Auditorium in the Student Union building. So I'd encourage you to come visit there as well. It will not be an exact repeat of what we're talking about today, so you can go and learn something there as well. So we have a fairly limited amount of time. I'm going to keep my introduction for Mr. Moses fairly short. I would like to make one note that we do have the birthday cake in his honor. We're very grateful that he was willing to come on his birthday. So just a little bit of background for Mr. Moses here. He earned his BA from Hamilton College in 1956 and his master's in philosophy from Harvard University in 1957. He was a prominent figure throughout the 1960s civil rights movement, working for several different organizations, including service as a field secretary for the Student Nonviolent Coordinating Committee and director of that group's Mississippi Voter Registration Project. In 1982, he received the MacArthur Foundation Genius Award and subsequently started the Algebra project, which uses mathematics as an organizing tool for a quality education as a constitutional right for all students. With support of the National Science Foundation since 2002, the Algebra project has been working with cohorts of high school students who previously performed in the lowest quartile on standardized exams. And believe me, if I were to continue on with the discussion, I could take up the full 45 minutes talking about his many accomplishments and efforts focused on civil rights as well as education since the 1980s. But you're not here to listen to me talk. We're here to visit with Mr. Moses, and so I would hope you can join me in welcoming him to Adams State University.
Thank you. So, Matt, can you stay right here? Can we get you to come up? Yeah.
Sure.
Yep. So we're going to work together. Maybe, how about you? Come on. So, yeah. We need a little differentiation. Yeah. Not gender-wise, but. Okay. So, and those of you who don't have pencil and paper, we're going to ask you to get pencil and paper. So we're going to put you to work, and we're going to try to look at this question up here. How does the language which we all own help us to access the language of math and science? And so our first question is really, who is taller? We know Matt's name. I know Matt's name, and your name is?
Leah.
Leah. And so answer the question, write the question down, and then answer the question using both their names. And it's not a trick question. We expect everybody to know the answer. Right.
Can I pass out?
Yes, so we pass out paper, and please, you should get to work. We're finished. Yeah, there's nothing else. All right, so who has an answer? Yes. We're going to move this right along because we don't have much time. Just anybody give us the answer? Yes.
Matt is taller than Leah.
Yes. Everybody agree?
Yes.
Good. Okay. And so the next question is, what feature of Matt and Leah are we talking about? We're asking everybody actually to do this. Yeah. So just write down. We're clearly not talking about their weight. What are we talking about? height, right. So the feature we're talking about is height. And so the next thing we're going to ask you to create a name for tallness for each of them, the height of Matt and the height of Leah. And let's label your first sentence A, right? Matt is taller than Leah. And then label this next sentence B. So you're going to rewrite A and change the names. So instead of Matt and Leah, you now have a new name for each of them, the height of Matt and the height of Leah. And so write your sentence that tells us the same information, who is taller, but uses different names now. Leah is L-E-A?
Yes.
Okay. Somebody? What'd you write? Anybody? Yes.
The blonde man is taller than the brunette one.
No, no.
Okay, I didn't get it.
The name, yes.
HM is taller than HL?
Well, the height of Matt. Let's actually don't make it more sophisticated than it is. It's just a new name for Matt, and his new name is the height of Matt. That's his new name, right? We just created a name focusing on the feature that we're interested in, not his weight, but his height. So the height of Matt, and you want to finish your sentence, and you're going to end it with the height of Leah. So you had a sentence here which has two names, Matt and Leah, and you're describing a relationship between them, right? Matt is taller than Leah. No problem with that, right? And so now we want to rewrite that sentence using different names, the height of Matt and the height of Leah. Anybody? Yes.
The height of Matt is greater than the height of Leah.
Okay, the height of Matt is greater than the height of Leah. Anybody, everybody okay with that? All right. How many did that? So now you want to ask yourself a question about sentence A versus sentence B. This is A and this is B. And the attention now is on the sentences themselves. Where is the information about height encoded in sentence A versus where is it encoded in sentence B? Right. Anybody?
In sentence A, it's encoded in taller, and in sentence B, it's encoded in the height of.
Okay, so in sentence A, it's encoded in this part of the sentence, and in sentence A, it's encoded in this part of the sentence, right? So do you have a way of thinking about the grammatical structure of sentences like these? Do you have a way of naming those grammatical structures? In other words, we're pretty clear that Matt here that's written is a name, and I just told you that I made another name called the height of Matt, right? So we can say, okay, these are names, Matt, Leah, the height of Matt, the height of Leah. Do you have a way of naming is taller than and is greater than, as just structures of language? Anybody? Yeah.
Verb, a noun. Verb.
So you would think of these as a verb here, okay? And these as a verb, this as a verb here. Anybody else have a way in which they think about this as grammatical categories or names? You have a way of thinking about it?
The connection between the two.
A connection, okay. A connector. Connectors.
Comparison.
Anybody else? Comparison.
They're all parts of speech.
When you say that, you're saying that this phrase here, the height of Matt, is a part of speech, and this is a part of speech also. Who said that? Right? Is that what you were meaning? Yep. So, but the question is, do you have a way of naming these parts of speech? Do you think of them as different parts of speech? So, in your own mind, do any of these work better than others?
Isn't it an adjective?
Adverb.
Adverb.
Adjective describes a thing. Adverb describes.
Okay, so here's the thing. Whatever you want to call it, right? Information has been taken out of one part of speech and placed in another part of speech, right? So whatever you want to call these parts of speeches, right? Some information has been taken out of that part of speech and put in another part of speech. This way of talking is kind of the way we talk, right? This way of talking is the way that math and science talks, right? They create names and they move information out of parts of speech that we use in our ordinary discourse and put it in the names or put it someplace else, right? And so that's what we're trying to look at, how our ordinary language is a bridge, how we can use it as a bridge into the languages of math and science. So I'm going to ask you to make something that we will call a height chart representation on your paper. So just draw a line, put a mark, and one mark, just call it the height of mark, or height mark for Matt. And the other is the height mark for Leah. And we'll just imagine that Matt is about how much taller? 2 inches? 3 inches? 3 inches. It's about a 3 inches different from. So now write a sentence about that. And use Matt and Leah, just use their names, and write a sentence about that answers the question not who's taller, but how much taller is Matt than Leah, right? and your answer. Let's call this sentence C. Is everybody writing? Okay. It's really important that you write, that you do your homework. Right? Anybody? Yes. Again, it's not a trick question, so everybody should have the same answer. Matt?
Matt is 3 inches taller than Leah.
Yes, Matt is 3 inches taller than Leah. And here we have names. And then here we have whatever we're going to call this. But all of a sudden there's more stuff in there, right? Over here, all we had in there was is taller than. And now the way we speak, we're just putting more stuff right in that same place, right? Whatever that part of speech which we're not sure what to call it, right? All right, so if we go on and do our feature talk, right, and just say the height of Matt is 3 inches greater than the height of Leah. Well, we still have our two names, but we still got all that stuff, got more stuff in there. So math isn't going to let us keep it in there, right? I mean, math is going to make the same move that we did over here. It's going to say, take some of that stuff out and put it someplace else, right? Develop another category, right? So we have an idea about the category because someone said, well, what's going on is comparison. So here's what I'd like you to do. I'd like you to figure out, well, how would you take the stuff out of here and rewrite this sentence so all this stuff isn't in here? What different ways might you rewrite it, right? So just think about it, talk to somebody else. See about all the different ways you can rewrite this sentence without having all this stuff in the same place here, right? So talk to each other.
Oh, yeah. He's going to get rid of the middle part. Oh, yeah. Keep going, turn on.
So could we get some volunteers? would you like to come up and write your sentences or just say them out loud? But it'd be great if you're willing to come up and write them down for us. Did you write some sentences? Yeah. Yes.
X equals y plus 3.
Okay.
N is greater than L.
So we know what the 3 is, right?
Yeah.
What is the plus?
And. It's an and.
Greater than?
No, it's an and.
Somebody is saying it's an and?
Yeah.
All right. So X is what?
Height of Leah.
No. Not a,
The height of Matt? The height of Matt? Okay. And Y?
is the height of the
The height of Mia? Of Leah? Okay. And equals?
is.
Is. Okay, so you want to read it using those translations? The height of,
Matt is the height of Leah and 3 inches.
well, you didn't say the addition sign is plus.
We said and.
So how are you going to read the addition sign?
And.
And? So you want to read it again using and?
The height of Matt is the height of Leah and 3
Inches.
What's your sentence? How many people like that? Nobody likes your sentence. All right, we're looking for sentences. Anybody got another sentence? Yes.
An additional one. X equal is not equal. Is more than sign. That little more than sign. Y. We don't have the specific there. But we do.
Okay,
X is more than
so
Y.
how do you read this one?
X, the height of Matt is greater than the height of Leah.
So that looks like you are doing this one.
Yeah.
Okay. All right.
And
How many people like that for this?
Yeah.
Well, let's get a show of hands. How many people like that as a way of... Okay, so you did better. We're in better shape with this so far than we are with this, right? Okay, so we're still working on this one then. Anybody else got a different way of writing this sentence here? Matt is 3 inches taller than Leah, right? Yes.
Would it be x is greater than or equal to y plus 3, or no?
Okay. Are you asking me a question or are you giving me a sentence?
Greater than.
Huh?
She says she's in better shape because of the greater than.
Okay, x is greater than or equal to y plus 3. And how are you going to read that?
The height of Matt is greater than or equal to the height of Leah plus 3.
And you still are using plus for the addition sign.
And.
I mean, what does plus mean for you?
Addition, add.
It just means add.
Yeah.
So, okay. So, all right, plus. How many like that one? You didn't get, not too many converts. Yes?
Change the addition that plus sign to by 3 inches.
By 3 inches. So you want a new way of reading the addition sign. Okay. By 3 inches. Okay. So you want to read it?
So the height of Matt is greater. Oh wait, the height of Leo.
The height of, this was the height of Matt.
Of Matt is height of Leo. Oh, I was looking at the top one.
Oh, you-
Yeah,
okay, well, how you want to read that then?
the height of Matt is greater than or equal to the height of Leo by 3 inches.
By 3 inches. Well, we have to vote on that first. How many, they're asking you to speak louder so they can hear you.
Well, for the greater or equal to, just take off the equal to.
Okay, we're down here, equal to, okay. So we have a whole nother one then. Okay,
That's not true.
That's not true, yeah.
It's equal.
are you going to read it or?
Yeah, the height of Matt is greater than the height of Leo by 3 inches.
No, it's not. They're equal then, if it's y plus 3.
The height of Matt is greater than the height of Leah by.
Oh, yeah.
So let me ask you, this plus sign here, the 3 is already here. So this plus sign, you just wanted to read by? Okay. By. All right. So the height of Matt is greater than the height of Leah by 3. Or by 3 inches. How many like that? Couple. Somewhat. You, huh? Yeah. Well, we're not voting. We're just we're polling. Okay. Someone else wants to go? Okay. Here's what I'd like you to do, because our time is crunching us. I'd like to work with this idea that we are comparing heights. And I'd like you to use the phrase compared to. And I'd like you to work with this using that phrase. So how many ways can you write a sentence which is telling us that the height of Matt is 3 inches greater than the height of Leah using compared to? That is, that what we're doing is comparing their heights. So let's make it explicit, right? So write some sentences using that.
Yeah.
So I'm going to use H of M and H of L for the height of Matt and the height of Leah. Somebody got a sentence? Yeah.
Well, I don't know if this is
Yeah, sentence, just a sentence. Yeah.
Compared to Leah, Matt is 3 inches taller.
Okay, use the height of Leah. Okay, compared to the height of Leah, the height of Matt is 3 inches greater. Okay. All right, somebody got another sentence using compared to, yes.
The height of Matt compared to the height of Leah is greater by 3.
The height of Matt compared to the height of Leah is 3 inches greater. Yes, I'm going to standardize that. Is 3 inches greater. Another way of saying it. Any other way of working compared to in there? Yes.
The height of Matt compared to the height of Leah added to 3 inches is equal.
Okay, I'm going to go with this version for purposes. Anybody else? Yes. Say, I'm sorry, I couldn't hear you.
The height of Leah compared to the height of Matt is shorter by 3 inches.
Okay, so I'm going to not use it because we're working with is greater than, right? So we could have another one, which is the height of Leah is 3 inches less than the height of Matt, but let's not do that right now. We got enough trouble with what we're working with here is greater than. Anybody, one more way of working compared to in there?
About the height of Matt is 3 inches greater compared to the height of Leah.
There you go. The height of Matt is 3 inches greater compared to the height of Leah. So which of these does mathematics actually formalize? Which does mathematics prefer?
The last one?
Okay, how would you formalize it? Using your variables here. We have a variable for x for the height of Matt and y for the height of Leah. So how would you formalize that using x and y?
X equals 3 plus L. Or X equals 3 plus Y.
X equals 3 plus y. So where's compared to in that formulation?
Equal?
There isn't.
Yes?
There isn't a symbol for as compared to, I don't think.
Yes, so in that formulation, there isn't a symbol for compared to. And we might think of this as an arithmetic way of working this problem. Okay, anybody else? X minus y equals 3. X minus y equals 3. Yes. And where is the symbol for compared to?
Not there.
So the minus sign represents compared to.
Equal.
The difference.
Is equal, is compared to is equal, comparing two sides.
The equal sign, how do you want to read this?
No.
The equal sign.
Is compared to.
So read the whole thing.
The
Height of Matt
Matt
Minus the height.
minus the height of
Leah
Leah is compared to 3. It is equal
is compared to 3 or is equal to 3? Which? Is compared to 3. Okay. Suppose we just read it, the height of Matt compared to the height of Leah, right, is equal to 3. You don't know?
The height of Matt less the height of Leah compares to 3. I say the height of Matt less the height of Leah compares to 3.
Okay. So, our problem, of course, is around the greater. Suppose I did this. What am I saying now? Yes, the height of Leah compared to the height of Matt is 3 inches less. So up here, the height of Matt compared to the height of Leah is 3 inches more, except that we don't put in the more, right? That is, it's kind of understood, right? Okay, we're going to try to wrap it up because we don't have much time. So actually, compared to in algebra is represented by subtraction. In arithmetic, subtraction is take away, sort of, or difference. This is a little different because the difference is not just a positive number, so it has direction, so you can compare in either direction, right? But what I wanted to emphasize here is the relationship between the ordinary language we speak and what gets formalized into mathematical language, right? And I just want to briefly outline a way of thinking about that, what we just did. So from time immemorial, people try stuff, right? And then they think about it, and then they improve it, and then they practice. So you're cooking, you taste it, right? You make changes, you get a recipe. Swimming, you know, all sports, right? So it's all over the place, this way of developing knowledge, right? At the end of the 19th century, the beginning of the 20th century, this got formalized as experiential learning. There's an event, there's reflection, there's conceptualization, and application. So there's Piaget, there's Lewin, there's Dewey. So these names are associated with that. It got into progressive education at the beginning of the 20th century. In mathematics, it worked for the first 3 grades, and then you got into long division, and you got yellow ditto sheets, and it stopped. I was at Harvard in the 1950s, 1956, 58, and Willard Van Orman Quine was the star of Harvard's philosophy department. And he was also a mathematical logician. And he said three things. He said elementary arithmetic, elementary set theory, elementary logic get off the ground by what he called the regimentation of ordinary language. You take the languages that people speak and you, so to speak, straitjacket them. And you get a language that nobody speaks. So nobody goes around saying, you know what? The height of Matt is greater than the height of Leah. You have never heard anybody say that, right? So what he worked on was how that language, the conceptual language, relates to the language of math and science. And he said that all of the representations, the x's and the y's, all of those abstract symbols that we see in the math and science textbooks, right, they are representations of this conceptual language that nobody speaks. And there are certain things that follow from that. One is that there's therefore no privileged linguistic access to the languages of math and science. Speaking the King's correct English does not get you access to the language of math and science. So everybody who has a language which they can get around the street with has a language that they can use to access math and science. So what we did was take Quine's ideas and marry them to experiential learning. And after there's an event, our little event here was, you know, Matt and Leah, who's taller. But after the event, ask the students to construct people talk. So that's their talk about what happened, right? And then ask them to identify features. We identified height here. And then ask them to identify, to develop, you have to help them develop feature talk. So that's what we were doing here. So we have some very outlandish feature talk here, right? Using a feature compared to. And notice we introduced a different category. So basically, we've worked our way through three categories here. We've had names. We've had relations, is taller than, right, is greater than. And we've had operations. So compared to it's a mental operation. You compare different things. And so in the language, in the vocabulary of math, those are the three basic kinds of symbols, right? You have symbols for the names, right, the variables which hold a place for names. And then you have your operations, addition, subtraction, so forth, which in the language we speak are representing actions compared to as a kind of mental action. And then you have your relations, right? So those basic three symbols. And then in the algebra project, what we do is we ask the people to do representations of two types. One is iconic, that is, develop their own symbols, and the other is standard. As you can well imagine, you moved right away to X and Y, the standard notations. The kids are better off if they wrestle with working out a symbol for compared to and figuring out how they would want to represent, right, this information in symbolic form, making their own symbol for height, right? And getting the idea that symbols are made by people and they mean something, and you have to go through the process of constructing your own symbols so you can understand that whatever symbols are thrown at you in the math textbook, somebody made them up and they intended them to mean something, right? And so this little schema here informs the Algebra project pedagogy. There is a group of mathematicians and math educators in Colorado who are doing something with that. Let's put up here Jody Novak. At unco.edu. And it's 1-970-351-2463. So Jody Novak is a research mathematician, and she's also really deeply interested in the teaching and learning of math in school math. And she also is part of people across the country who are partnering with, in different ways, with the Algebra project around this issue. I'm going to stop, so we have a few minutes. I'd like to just say one thing, that the whole issue of the language which we speak and its relationship to the formalized language of math plays itself out on a much bigger scheme in the country in terms of the idea that we are a civilization that has inherited a law about human behavior and what constitutes the substance of human life that has been formalized in constitutional law, right? And we argue all the time in this country about the differences between our concept of law and understanding about how people should relate to each other through what they have been passed down through the ages and what we have formalized in our Constitution. Right? And we really don't understand the interplay between those. We don't have good ways of really talking about the interplay between those. And I will talk about the history of that interplay tonight. And we have time, I think, for one or two questions, because we've got to be out of here by 5 o'clock.
We have about 6 or 7 minutes.
Yes.
Okay, so this process that you put us through made me really think that it's hard to go back and forth, especially as you get older. And so, can you explain how this pertains to your project in terms of what is it illustrating around young people and people learning today?
So what we have done, we've been working at this for about a quarter of a century. We've actually rounded up some research mathematicians willing to work on this. We've been targeting the bottom quartile of the economic distribution, right? And asking what do they have to do as they leave 8th grade, entering high school, to commit so that when they leave high school, they're ready to do college math for college credit, right? So this is a huge national problem. And we have been working on the what to teach it and how to teach it, so these students would be willing to double up on their math for 4 years of high school. So you can't make them do that, They have to be willing to do that. But the biggest reason why they're not willing is they don't feel that they can do it, right? And so we have been using this process not in the concentrated form that we did it here, but in a way in which the students begin to access through their language, the language of math and science, and become convinced that math is something they do. Having been convinced for the first 8 years of their schooling that math is something they don't do, right? And so we've been working real hard at this, and we think we know how to do it. The big problem now is, well, how do you get the adults and the whole political system, which has never had any interest in actually the bottom quartile of the nation's economic distribution, being educated to actually compete, if you like, and be citizens in the fullest sense in the country. Does that answer your question?
Yeah.
Okay.
Any other questions?
How do you influence students that are liberal arts majors to learn the importance of mathematics throughout life?
So I think the basic argument has to be in terms of the planet-wide shift from industrial to information age technology. So the 20th century, reading and writing were the primary literacy skills to access, be a citizen and access the economic arrangements. On the math side in the 20th century, they wanted you to function at the post office, right? So if you had enough arithmetic to do that, you were okay, and you could go to college and brag. I don't do math, right? Right? And it was okay. So the computers bring quantitative literacy on the table in the same way that reading and writing were on the table in the industrial society, right? And so we have an additional literacy. We are not going to get out from under it. In our country, it's algebra, which is the gateway into that literacy. In France, it's geometry. But in our country, it's algebra. And so students need to understand that they're going to be parents, even if they are liberal arts majors, right? And their children are going to have to deal with the literacies of the 21st century. And quantitative literacy is not going to go away. And if they want to help their children, then they need to get on the stick and decide that they're going to be 21st century parents.
So maybe one more question, and then I think we're going to have to end, and then we can have a little bit of conversation in the hallway. So,
What are the instructors who are using this methodology using to motivate those 8th graders to double up on the math? How?
So there has to be really to make it work, there has to be an induction process. You got to grab them preferably during their 8th grade year. And we have a Young People's Project, which works with kids after school. Then you got to get them and their teachers in the summer before they go into 9th grade, right? There has to be a serious induction process whereby they begin to see that, ooh, maybe this is something that I should pay attention to. So people ask me, well, what does it take to teach algebra? And I say, well, you need 2 things. They have to be able to count, and you have to get their attention. So it's getting their attention that's the real issue.
well, thank our speaker, please.